This is a tutorial about how to place the generative component's LawCurveEmulator generated node type. I recommend that you review the wiki entries introducing LawCurves and the LawCurveEmulator generated node type or GNT before watching this tutorial. This tutorial starts with a review of how to load generated node types and where we find them in generative component's user interface so we can put them to use. Next, we place the LawCurveEmulatorGNT and retrieve the value of the dependent variable, which is the main reason for using the LawCurveEmulator. Then we will review how to access its optional input properties. The tutorial ends with a suggestion for next steps. How do we load generated node types into a generative component session? We access the load external assembly command through GC's primary tasks under the Show Graph icon, or through the Utilities menu, Manage Node Types, Load External Assembly. Through both of these routes, we reach the Manage Loaded Assemblies dialog. In it, we can either load project assemblies or Bentley product assemblies. GNTs are project assemblies. Because when we created the LawCurveEmulatorGNT, we selected the option to store it in our GC environment, that GNT is already loaded. In any case, when selecting to load project assemblies, GC will open the default project location into which GNTs will be generated and to which you should download or copy any GNTs you may receive from collaborators. We select the GNT we want to load and the Open button. A confirmation will be shown that the selected assembly was loaded successfully. I usually select the Stored in your GC environment checkbox for GNTs that I load so that they will be available in future sessions of GC. The loaded GNTs are placed in their own generated section in the node types palette. From here, they can be placed per drag and drop into the graph like any other node type, effectively creating an instance node of that node type. The required inputs for the LawCurveEmulator are shown as input ports on the node. They are a coordinate system as placement seers and a list of points as curve points. We place the coordinate system per drag and drop, switch it to use the Add Model Origin technique because that is the only input that we have available for any of the techniques that generate coordinate systems, and select the currently open default model as the model in which the coordinate system should appear. This will also be the model in which the LawCurveEmulatorGNT will be placed when using this coordinate system as input to placement seers, because we set that property to determine the parent model for the LawCurveEmulatorGNT when we created it. Next, we place some point nodes interactively in the model, activate the input property editor for curve points, placing the insertion cursor in it, and then frame select the points. They will be entered as a list into the curve points input property. We confirm by either an empty click into the graph or by hitting enter. Now we can adjust the view to be a parallel projection of a top view by switching the camera for the geometric view off and selecting the top view as view orientation. Next, we record a transaction which captures everything necessary for successful placement of a LawCurveEmulatorGNT. In order to retrieve the value of the dependent variable, we place an expression node to which we wire the LawCurveEmulator's dependent variable output property. With a second consecutive expression, we can test how we would get the actual list of double values that corresponds to the list of double values that we passed in as independent variable input. Here we need to retrieve the y property of the previously placed expression. Now we can move curve points to test how the dependent variable y, as we have named the second expression, changes values. If I wanted to customize the LawCurveEmulator by using the input properties that we set to be optional and for which we provided acceptable default values, I can either access them by expanding the input properties dropdown on the node or by double-clicking on the node to open the Node Properties dialog. Here I see all optional input properties and can edit them directly to modify the LawCurve emulator. Of course, as in the script in which we created the LawCurveEmulatorGNT, I can set up sliders to provide input properties dynamically. For a single convenient access point to all control nodes that I have placed in my GC model, I can open the Controls dialog and modify parameters in a single place without having to navigate the graph. Before exiting, save settings to preserve the parallel projected top view in our geometric view window, and save the file to ensure the settings are written to file. What are next steps that we suggest you take? Learn how to replace an old-fashioned LawCurve with the LawCurveEmulatorGNT. If you have not downloaded Generative Components yet, you can download it from the Generative Components product page on bentley.com. This tutorial and other tutorials including example scripts can be found in the Wiki section of the Bentley community for Generative Components. Reviewing tutorials and examining example scripts will quickly open up Generative Components for you. Here are the URLs to the before-mentioned resources. The Generative Components Bentley community is also your primary point to post any questions about Generative Components.